This is part 2 of Unit 4, and this part 2 covers lofts. AutoCAD loft command. The AutoCAD loft command is capable of developing complex shapes. The loft command requires a minimum of 2 objects, and those objects need to be 1. A series of cross-sectional profiles. 2. The loft can be defined by just cross-sections or guided by adding either a path curve or multiple guide curves. The loft command in AutoCAD can produce both surfaces and solids. Just like the sweep command, which has identical rules of 1. Open profiles generate lofted surfaces, and 2. Closed profiles generate lofted solids. Loft cross-sections. The foundation of the loft command in AutoCAD are cross-sections. The command has many options and the ability to add constraints to control the shape, but every loft requires a minimum of 2 sections that are first single entities. If you construct a section with multiple entities such as lines and arcs, they must be combined using the join command prior to executing the loft command. In the example on the right, both the hexagon and the rectangle are single entities, not line segments. Second, the loft sections must be selected in order from one end of the series or the other. If the sections are selected out of order, the loft may twist or fail completely. In the example on the right, the sequence would be either to select the hex, then the circle, and finally the rectangle, or in reverse order. The circle would never be selected first or last. The third is the profile edges of existing solids may be selected using the multiple edge option, which allows the edges to be selected and the resulting loft will blend the 2 solids together as shown on the right. And lastly, points may be used in a loft, but they can only be used for the first and last sections in the series. Now let's go to AutoCAD and see how to apply the loft command using only cross sections and how the variety of settings affect the resulting shapes. Okay, here we are. This is the loft sections example. Now there are a lot of parameters with the loft command. So what I'm going to do is do the same loft several times, and we're going to play with the parameters so you can see what the differences are. These examples are all just 3-section lofts that are controlled by sections only. And again, it's important that all your entities are joined. So like this is a polygon and not a bunch of line segments. And this is a polyline, not just 4 lines. All right, so we're going to go to solid. And I'm actually before that, let's go ahead and go to shaded. We'll see if this is going to work for us. And we're going to go to solid, and we're going to toggle from sweep to loft. Now it's important that you select your sections in order. It doesn't matter if you start on one end or the other as long as you're consistent. What I have found for the success rate of lofts is it's also helpful if you select on similar corners or edges so that the chain is going the same direction. So out of habit, I'm going to pick the area right here. Then I'm going to pick the circle in about the same place. And then I'm going to select the polygon with the closest corresponding corner. All right. So at the default settings, this is the result, which is called smooth. We're going to hit enter to accept that that's all of the sections we're going to use. And now I'm going to go into settings. And a dialog box should appear. So our default is smooth fit. So it's doing a smooth transition, blending between them. And none of the other options are selected. So we're going to go ahead and hit OK. And this is what our loft resultant looks like. Has a little bit of a twist line going from each corner to the base. Alright, now let's repeat that. We're going to pick our 3 sections. We're going to accept those sections. And let's go to settings. Now we're going to select the ruled radio button. What that does is it doesn't smooth anything. And technically you should be able to put a ruler across each section of the loft and not see any light under it. It's as if it's a flat transition between them, facets. And we'll select OK. Now if we zoom in, you see that we have basically our resultant goes from a square to a cone and then back to a like a diamond shape. A little different than the smooth transition. The resultant of this would be the same if you were just doing a loft between 2 of the sections at a time and made separate pieces. Not generally what you use a loft for. Okay, so let's go to the next example. We're going to make a loft and we're going to select our entities. And we're going to hit enter to accept those. And we're going to just do settings. And we're going to select normal 2, which allows us to have several settings. So you could have the start cross section, it's always going to be normal 2, the end cross section, the start and end, and all cross sections, which is the default. So it forces the shape to maintain normal curves to it. So we'll hit OK. So we have a slightly different curvature between these two. Alright, one more. We're going to go to Loft. And we're going to select our 3 curves. We're going to accept those curves. And we're going to go to Settings. And this time we're going to apply a draft. So let's pick on Draft. And a draft is an angle or a taper. It defaults at 90. 100 on one end and 80 on the other. It's not totally obvious what it did, but it adjusted the angles in the sections. So you can see it's shallower here and a little bit heavier at the top. So at my start point I had it more than 90 degrees, and at the other end I had it the opposite. Alright, we're going to do one more demonstration, and that's going to be to force this to be a surface. And we'll go to Loft. We're going to select our closed entities. And we're going to go to Mode, MO, and we're going to switch the surface. And then we'll hit Enter. And Enter again. And in this case, we now have a hollow surface rather than a solid. So you can force a closed shape to become a surface instead of a solid. But if you started with cross sections that are open, you're going to generate a surface and not a solid. Now we're going to move on to lofting between two existing bodies. So we have two bricks that look similar to what's in the textbook, and we're going to select loft. And we're going to use join, and we're going to select our edges that will make up the first section. And then we're going to say join again for our second cross section. And enter again, and we get a loft transition between the two solids. Okay, we're going to hit enter, and now we have a loft that goes in between our two solids. Okay, that's the end of our examples for single profiles. Loft with a path. The loft command in AutoCAD is a powerful tool with the ability to generate shapes with cross sections. Control of the loft can be enhanced by the addition of path curves with the following constraints. First, only one path curve may be used in a loft. Second, the path must be one continuous entity. And thirdly, the path is not required to contact the loft sections. In the example on the right, the loft is made up of 5 sections that are rendered in black, and one path curve running down the center rendered in orange. This loft configuration will result in the surface shown on the right. If additional controls are desired without adding more sections, guide curves need to be used instead of path curves. Loft with guides. The addition of guide curves to a loft provides the highest level of control to the shape. Guide curves can be used in conjunction with the cross sections with the following constraints. First, like path curves, guide curves must be one continuous entity. Second, guide curves must contact the sections. Third, guide curves must be selected in order. In the example on the right, the sections of the loft are the 2 circles rendered in black, and the 2 guide curves are rendered in orange. The guide curve on one side guides the loft to have 3 bumps, and the straight curve on the opposite side constrains the loft to be straight in its proximity. The resulting shape is the solid on the far right, which is a handle grip. Now we return to AutoCAD to see how both a path and a guide curve scenario are applied to a similar shape as the final concept in this lecture. Okay, here we go with our final 2 demonstrations. This is going to be a loft controlled by a path and another loft controlled by guide curves. The path is highlighted in red. The cross sections are white circles, and the guide curves are represented in green. I did something similar to what's in the textbook, although my hand grip looks more like an Easter Island head, I think, on the side. But here we go. So here's how they work differently. Okay, we're going to go to loft. We're going to select our 2 cross sections. We're going to select accept those, and then we're going to pick path. And remember, you can only have one path, so it's the red arc I have here. And what it does is it guided the solid. Now if I go to shaded mode, you see it's a loft between the two, but it took on the curvature of the arc. So it's combining somewhat of a loft and a sweep properties. Now let's do the same thing to this other one here. Go to Solid, Loft, select our two sections. We're going to accept that selection and we're going to select Guides instead of Path. Now we need to select our two paths and we get a preview here and hit enter and I get this weird Mobius looking thing here. So the section right through the back here should be a straight line and then it blends between the two. This concludes this lecture and I'll see you on the next one.